In this video, I'm going to show how to make a ray diagram with a convex mirror and an object that's very close to that convex mirror. Convex, remember, means that the mirror is bowing out. It's the opposite of concave. And as a result, all the rays striking the mirror are going to spread themselves out, and we get a focal point that's behind the mirror, and we get a center of curvature that's behind the mirror. If we extended the mirror into a giant circle, its center would be back there. Remember, the focal point is where all the parallel rays come in, and as they spread out, there's no real focal point, there's no real place where they all come together. So we have to imagine them extending back, and that would be the place, if you extended all those rays back, that they would all meet in a solid spot. Now, we're going to do our three rays here. Number one is going to go parallel to the optic axis, parallel to optic axis, and then it's going to bend through focal point. Now remember, for these ones with these virtual focal points, they don't really bend through the focal point, they're just in line with it. So here, you can see I come in parallel. Let me try and adjust that. I'm going to just try that again entirely. So I'm going to start at the... Now, what do I do here? Draw. Get that and that. Okay. I'm going to try and start right at the top. It doesn't want to get me there. That's fine. I'll just use that. And then that is going to bend in line with this focal point. So if I imagine, I want to be in line with this dashed line right here. And so it's going to bend away like this, in line with that. And then my second ray is going to head towards that virtual focal point, obviously not get there, and then bend parallel. So here's the ray. It's going to be headed towards this virtual focal point. Never going to get there, so I'm going to back it right up to where it was in line, but not there. Something like that. And then it's going to bend parallel. Like that. Now what we notice immediately is that these two real rays are divergent. Divergent means that they're spreading apart, they're not sticking together. And so they're never going to come to a point where they're going to intersect. And so there's no real image formed in this case. But instead, our eye has to interpret this image. It assumes that the rays travel in straight lines. And so if I extend it backwards, we can assume where it came from. And as a result, I get a virtual image right here. Now hold on, I'm just realizing a second here, I didn't write out what's going on with that second ray. For the second ray, I am coming towards the virtual focal point, then bending parallel. So again, since these two real rays that are divergent as they leave this mirror are never going to meet, we have to extend them back to see if they had come in straight lines, that's what your eye assumes, where did they meet in the past, or where beyond the mirror does it look like they meet. And what we get here is an intersection point back here, and we get an image. That image is smaller, a little, not that much smaller, but a little bit. It is upright. It is virtual. And it's a little closer to the mirror than the original object. So that's the ray diagram. I'm just going to do that third ray to make sure that it agrees with this, and then we'll be done. So remember, the third ray heads towards the center of the mirror, and as a result bounces back right along the path that it came in on. So the third ray starts towards center of curvature, then bounces back on itself. So that ray would start the same place I started the other ones and head towards that center of curvature. Now we can imagine it bouncing back on itself and that this is only virtual light, but what we can see from what I've shown here is that it intersects at the same location for the image as the other two rays, and so it confirms the location of the image as well as all the other properties of the image that we observed. So that's a ray diagram for a convex mirror with an object which is relatively close.